Wageningen research, and myself and the type of research that I've been doing that is related to the topic of this meeting. So Wageningen environmental research consists of two parts. We have Wageningen University and Wageningen Research, and then it's not very visible, but then I work at Wageningen Research, and then each of these there's like it's like a matrix, basically, our organization. So we have the agrotechnology, animal sciences, environmental sciences, plant sciences, and social scientists. And then I'm in this environmental sciences group, in which Wageningen Environmental Research is the part where I am working, which was formerly called Altera. In case somebody knows that, they changed the names because just to have some consistency in the names, and that it would yeah.
Come back again for the first topic. For the first one.
Yeah.
Thank you.
Okay. Yes. So so then I'm here in Wageningen. So the university has about 13,000 students. Coming from many different countries, in total 111 in this particular year. Most of them of the international students come from China, Germany, or from Italy. These are the top 3 countries where they come from. Then we also have about 2,300 PhD candidates currently. So in terms of employees, we are in Wageningen Research. We are 3,600, and the university has a bit less. And then I don't remember what this is. Well, you can see that we are relatively well organized in terms of female and male colleagues. Then, within Wageningen Environmental Research, there's a number of teams that work together, both in the university as well as in research. And they're maybe this picture is better for the Twitter. This one. Then since 2012, actually, it was initiated by a project that was led by Rolf. It was called Smart Inspectors, and it was an Interact project in which we tried to collaborate between the province of Gelderland and the adjacent province, which is in Germany, North Rhine-Westphalia, to bring some more economic development within these 2 regions, and also to facilitate their cross-boundary collaboration. And this project was about the use of drones and sensors, or actually unmanned aerial vehicles, as they were then called, and to see what type of research could be done with that. And then we had a follow-up project which was called Spectres, and then after that we didn't have any collaboration funds so much anymore, so we still need to figure out how to continue this. But the good thing was that within Wageningen we have launched this unmanned aerial remote sensing facility, a very long, bad name, which was thought of by one of my colleagues, and I've been telling him ever since that we should change the name, but he still is unwilling to do so. So I still struggle with this, to remember this name by heart. Anyway, so we collaborate, and every 2 weeks we have a meeting to see what kind of research are we doing in anything that is related to drones and sensors, and and we just update each other on all the things that we do. So these are the different platforms and camera types that we currently have to our disposal to use. So we have this, within Spectres, we managed to buy this super expensive EB thing that you can mount with different types of sensors underneath, being the thermal sensor, the RGB, and the hyperspectral sensor fit into this. And then we have the small Phantom and the Mavic that I've been using quite a lot, because I now have, to be able to fly these drones, you need to have a license, like you are a pilot. And then, but for the small ones, it is relatively easy to get. For the bigger ones, you need some more, it's also, it is a lot of hours that you need to maintain your license. So I decided to go only for for the small ones that you can bring in a backpack and go to measure anywhere you like. So that I did that a lot in Spain with some project that I will just very briefly touch on. So, but we also have a super big one that is this one that is like a big monster, even it's black with some red elements, so to make it show that it's really dangerous. And this is you can mount with a LiDAR, which is yeah, it is really interesting material that comes out of that when you use it. So why the main question of our facility is so which resolution can you use for which kind of question that you are asking? So we go from satellites, airplane, drones to in situ. It's a very old picture of my colleague Lammert. Very old picture. I think he was probably still a student at the time. But so and the idea mainly is also that these drones in the middle, because of course satellites and airplanes have been used for a longer period of times, and drones really enable us to link better the measurements that are done on the ground to get to the real remote sensing measurements. So what type of work do we do? We work with drone sensing in agriculture, nature conservation, forestry, erosion, and post-fire effects on soil erosion, vegetation recovery. We also do proximal sensing and satellite sensing, but I won't tell anything about that. So just an example here is on nature conservation, that we do this habitat mapping, and it links a bit to the stuff that also Rolf presented, to this object-based image analysis, and to see if you can identify not only individual plants that sometimes you also would like. We had, for instance, one project that was done in collaboration, I think also with one of your students. I'm not sure of that. I'm not sure what they're called in English. The dotter bloom. It's like a green plant that grows in the canals, you with this object-based image analysis, you could actually identify the individual plants. But this specific thing that you can see here was much more about to identify specific plant communities. So areas of vegetation that are similar to each other. So because that's the type of vegetation mapping that is done a lot by all sorts of companies that evaluate how well, or governmental institutions that evaluate how the nature is actually doing in a specific area, and then they just make cross sections and walk around to see which kind of habitats they can find. And then this was done here with this multispectral and multi-temporal satellite imagery. Then another one, this is the dotterbloemen that I was just explaining. So the species detection with these deep learning elements, and then also they did even counting sort of exercise with how many cows graze in a certain area on a certain time. It was anyway. Then we also have this, it is very close by to where I live and very close to the campus as well. It's a new nature area, and within this new project called SenseRes, which we are, we try to, because this area has just been developed from an agricultural area. It's originally, it's a peat area, and they excavated this partially to make a more wetter environment to facilitate this nature development. This here actually, Jesus, this river here, this little river is the one that we may go on with the sub on Wednesday afternoon when we come home. Anyway, so then we also did, we wanted to see after the initiation of this new nature conservation area, how the vegetation is developing over the first 2 years after the nature, after the project started. Then another side of also the SenseRes project was in Spain that I went only with the Mavic sensor, and this here is an almond orchard, and we've been monitoring this almond orchard now for 4 years to see how the erosion is occurring over and over again after really big storm events. And you can see here the amount of sediment that is here. You can see the reels, but also at the base of the field, you can see the accumulation of the sediment that has been.
How do you see that? Like just looking into the, let's say, in this case you use RGB camera on Mavic. Do you look into the color of the area, or just also?
It's the DM that we were trying to develop out of this.
Oh.
So, and then we also hope maybe to see how I can explain to you, like the other project that we have. I'm not sure where that is. No. The other project that we have is to detect the amount of organic matter in the soil. And I am not sure if we will reach anything with only the RGB colors. But still I want to try. We still did not crunch the numbers, or my colleague is supposed to be doing that, to see, because we have from this side, we have multiple a time series of RGB images, but we also have the satellite image, and we took samples of these sites of organic matter. So we want to see if we can find any relation between, and then we have the soil map, which in this case is not very interesting because it's all the same, so it's not very useful. But if we can see, if we can explain any of the variability in the actual amount of organic matter in the soil with the RGB images. If not, then we try.
Just interested in how the farmers or the growers are interested in that information. Like it shows that how the soil is washed down in some places, for example.
Yes, that's what it. I am. You can see here, for instance, that they plow relatively shallow, only about 10 centimeters of depth, just to uproot, just to make like to kill the weeds, and also to cut the capillary rise for losing the soil moisture. So this is the two reasons why they do this. And then you can see that when these reels occur, they go only up to the plow pan, but they still they lose a lot of their soil. How much of interest it will be for them, how much organic matter is in the soil, at the moment, I think they're not interested at all. But in case the European Union will decide that they are going to work with carbon farming everywhere, they might actually be interested in this. Because the European Union at the moment, the way they manage the subsidy system is that they give subsidies on the basis of the type of management that the farmer is doing. This is what they get money for. If you do strip cropping, you get this. If you do organic farming, you get this. But what they want to go to is they want to go to evidence-based subsidies. This means that they will actually give only subsidies if you can prove that you actually put more carbon in the soil. But at the moment, in my personal opinion, this is not possible at all, because there are no good evaluation tools to actually say how much organic matter is in the soil. You can measure it directly with a soil sample, but that's like super fraud. Yeah, also this, but it's also very easy to make a big fraud with this. You know, you take your soil sample, you put a little root inside, and then you have more carbon in the soil. So it's, yeah, and then what happens to the farmer that has, that has 5 years later, will have less carbon in his soil. They need to pay back all this, all this, and then it's just like 1 point. So they need this kind of evaluation tools. If they really want to go to this evidence-based payments, they need to have evaluation tools with which they can assess the whole field. because then you will, but at the moment there's still not any tool with which you can do this in a good way.
Saskia, you say you evaluate organic matter using RGB. Did you try to use the multispectral camera?
Yeah, well, we did this in another site. Wait, where is it? Here, this is a site close by our university. Where is it? So this is the project actually. So we use sensor data for downscaling digital soil maps to higher resolution. And we are, as Wageningen Research, we are the work package of the drone work package. So what we try to do is to make this, as I said, to get better information about the soil organic matter content in a higher resolution than the soil map gives you. And using these proximal sensors, drone images and satellite images. And then we focus on this soil organic matter, soil texture, and potentially, because we have different areas across Europe in which we do this. And then also some people are not only, I'm just focusing on bare soils. Some other people are also focusing on vegetated areas, which I think is very difficult. Anyway, so then we have a site, close to the campus, in which we actually did use also other data. So we did the RGB, but we also did the multispectral and hyperspectral and thermal sensing, but we still did not evaluate any of the data. So, and then we also tried to do this in Spain in both this almond field and also in a vineyard. We did the same. And we took samples in the field to see the actual data, basically. So let's see if how useful this will be, but I skipped a whole lot of things. Anyway, so we also in this, as a more hobby project, we try to work on erosion and sediment transport in these new fields, orange plantations in Spain. We also did research on post-fire effects on soils and how this post-fire management has an impact on the recovery of the vegetation. This was done with a colleague called Manuel Lopez Vicente, that you probably know. And we published this in 2 papers. That this one was, this site was close to, anyway, it doesn't matter, somewhere in central Spain, in Jaén. And then there was another one that was, what was this? No, this one was in Jaén, the other one was somewhere else. Anyway, so we tried to look at the sediment connectivity according to these post-fire management, different types of post-fire management, or not doing anything. So this was we tried to evaluate, because sometimes when you look at an area which has been treated after the fire with post-fire management strategies, I'm not sure if this is actually beneficial for the site in terms of vegetation recovery. Because sometimes the bulldozers that they need, or all the disturbance that they make with the machinery and the cars and everything that they go through, this very fragile ecosystem after the fire, is not what you would like. And then we made an evaluation here with these small-scaled barriers, and in the other case it was a larger area. No, this is actually the same site. I think this is the other site. So we tried to see, specifically look also to the native palm that you have in Spain, how well it recovers after these forest fires, depending on whether you are using these post-fire managements or not. And we found that for some species it's not the best thing to do. Maybe the first year it still looks positive, but if you look on a longer period of time, it is actually either the same or even better to do nothing. And then So this is something that we try to tell to the managers of this type of regions. Okay, so then yeah, I think I will stop here with my.
We can make a short question.
Sure, as many as you like. Where's my last slide? Here, with this beautiful picture taken by Artemi.
This area that Saskia is showing, the mountains that are in front, now are burning. More than 5,000 hectares last time. This is what we expect in the future, because Europe recovered a lot of forest or plantation. And there is less than this population in the rural area. Then we expect that forest fire will grow a lot.
Yeah, and you see here this plant. This is the native palm that you have in around the Mediterranean, and it's not really a tree. It is not the traditional palm, but it has multiple trunks. And this plant is completely adapted to fire. Actually likes to have it sometimes because it's like a haircut. Because it is you know, after not being burned for a long time, it starts to have a lot of leaves that are dead, and it doesn't look very healthy. And then it burns, and then after how many? 3 weeks?
This is
Not even?
it's 2 days.
2 days, it already has this. So it recovers very quickly from the fire. And then the question then is, do the post-fire management people still need to come and do something about this?
You know, the problem is when we try, you will see that many policymakers, they try to avoid that any fire will take place. Then we are selecting the species that are in the forest. Then if you have fire, you have some species. If you avoid fire, there are other species. And this forest, they evolved with fire always being recurring. This is Camerops humilis. Is the only. The people say that it's the unique palm from Europe.
Okay.
Okay, and it's true because all the other palm trees that you will see in Spain, in Italy, they come from North Africa, were transported and planted. And but it's not true because I said it because Janis is here. There are some islands in Greece that they have another type of palms. But in continental Europe is the unique palm, original from Europe. But in some islands of Greece there are some other palms that are also original.
And what season was that this fire?
July.
July.
July 2018.
How did they put it down with the water? Maybe they put it in a lot of water.
No. It's unbelievable that 3-4 weeks after a fire, you have 10% of recovery. There are many sprouted, many plants that sprout. And in the spring after the fire, then there is many plants that they have out of seeds. And the seeds are activated by the fire. Not only because the heat that remove part of the cover of the seed, and then it's easier to germinate. It's also because you create a ice bed, which collects a lot of water, and then you have a lot of nutrients. But also we found that some seeds germinate better if they have a smoke.
What do you mean? You were like a roasting the
No,
seeds is
if
better
the
for
smoke,
germination.
if the smoke pass through them, they germinate better. You know, how a seed decide to germinate? Which is the reason? It's water, it's temperature. But now we found that in the Mediterranean is smoke. It's unbelievable. Then all these adapted fire ecosystems need fire. And now how we tell the people that fire is not so bad? It's part of life. This is, but your presentation, there is one thing that is very interesting. Can you pass again the presentation of Saskia?
It's still there.
It's still there.
But, oh, it's no, it's not. Which
No, because
which one do you want?
one of the, I think we need to project like FIRElinks to see the whole view of the environmental problem. Then you will see many times that the fire is bad treated because increase the amount of sediments that reach the rivers. And erosion is enhanced. You have less vegetation cover, soil that can be affected by the heat, some of them lose the structure, then when the flow is connectivity. The system is better connected. And the transport of sediment is easier, okay? Then can you pass one of the pictures of the agriculture?
Yeah.
Okay. Where is the connectivity? Then we are in the forest land. We say that forest fire are very bad because increase erosion. But this is an almond field.
Yeah, one time,
This is
that.
a rough calculation is each kilo of almond is 15 kilos of soil lost.
Yeah, also, another issue is,
Gonna produce.
and yeah, because it's still very small. Now they're producing after like 4 years or so. When you paste a picture in your Word document, sometimes it gives you like an automatic caption. Do you know that?
No,
So you probably don't use Word.
I use it, but I've never used it.
Anyway, sometimes it does that. It gives you an automatic caption. And I pasted this picture or some similar one, and it gave me a desert landscape.
Oh, yes.
What?
Desert landscape. That is our agricultural field. Is classified by the probably is a deep learning something as a desert landscape.
Show them how bad.
So you plant almonds or oranges, they are a small plant, very little, almost under little leaves. And then for 1, 2, even 3 years, the cover is below 5% of the land. And they plow or they use herbicide, and it's completely bare.
Also, what they do now is that they destroy a lot because it's easier for mechanization. They destroy a lot of this traditional landscape with terraces, making an enormous environmental disaster in terms of erosion. Very bad.
But the issue is that in the news and sometimes many scientists they use forest fire to claim that this is the reason to fire or this place. It's agriculture. The main problem is agriculture. And in your country, in Crete, your island, also grazing, overgrazing.
Probably. I wanted to ask you, because you said that the fire is part of the ecosystem. My question is, where are what's the range of the fire, both in
Just the microphone.
Yeah.
It's for the video stream.
Okay,
Sorry,
so,
I didn't want to disturb you. Just go on.
what is the range of both in on how big it should fire be, and how much it should last for it to be actually beneficial to the environment?
Fire breaks.
Yes.
The fire breaks, you're talking about fire breaks, the land that...
No, okay, you said that you actually trying to convince the policymakers that the fire is part of the ecosystem, right?
Yeah.
So I'm asking, what are the parameters?
Please go.
What are how big should the fire be in order to be beneficial, and where does it start to be a problem?
Okay. Okay. If we want to imitate nature, in nature without humans, the forest fires will be huge.
Okay.
Okay. Still in the 19th century, in the United States, there was fires that almost crossed all the states, one state. When you had a lot of a big forest, no stop. Imagine that Crete will have a huge forest, and you have west wind, and the fire starts in the west, it will burn everything under natural conditions. And if we allow this, then we will have big forest fire, and we should accept because it's natural. The problem is in Crete there are a lot of buildings now, a lot in investment, urbanizations, towns, and then we need to create a human management to avoid this big fire that will take place once every century, but will take place. Then my proposal is that we will burn like 1% of Crete every year in winter where we can control the fire. And then have spots of areas burned with the different, every year they will be 1 year older, and then they will have a flora and a fauna that will evolve in this direction. In this way we can have forests that will be protected by other prescribed fires, and they can be 1 century or 1 millennia old. Under natural conditions they will be never 1 millennia old because they will be burned. Okay? Then we need to decide if we want a landscape managed by nature or managed by humans. In the past, in your country, farmers, shepherds, they managed the land. And they decided what was burned and what was not. Okay? Until now, these people is not there anymore. In some parts of Spain, the density of population in rural areas is below the density of population in Siberia. There are land in Spain that you can walk for 50 kilometers. I don't see any people. And then this is what is going on now, that they start to burn. In Zamora, which is a province nearby Portugal, this summer we have a forest fire with 50,000 hectares burned. Why? It's open land with nobody around. Some of them, in this case, afforestation with lepo pine, with lepo pine. Then my proposal is 50,000 hectares. 50,000 hectares. Let's go to burn 500 hectares every year in different spots. No 500 together, but 20 here, 10 here. No. These should be decided by ecologists, by farmers, by policymakers, by citizens, by landowners, by shepherds, by us as a scientists.
Thanks a lot.
And this is what FIRElinks should do. Bring this knowledge to make that we decide what we want to do in an agreement.
That's really nice idea, how and where to burn the forest, like the idea for the project. How to burn
Are you able to control it?
One of the most advanced firefighters group in Europe and in the world is from Catalonia. And they invest a lot of time to burn the firefighters. But the region nearby...
They don't want to be called firefighters anymore, they want to be called fire managers. This is the issue also. We had like the whole idea that fire is not something to fight. That fire is something that should be managed in the landscape. And that is the key difference. And we had also in one of the in the Fire in Your Earth System meeting last year in November it was, or October, when was it? We also had a session on media coverage of fire, and a lot of the media is always a nightmare. It's a drama. That the fire, there is a big wildfire, it's a drama. People killed, the house was burned. But you know, there is a need also for explaining that the fire can be managed in a way that it's beneficial for nature, and it doesn't need to be bad for the people that live there if it's done in a proper way. So that's why they call it fire landscape management instead of firefighting.
But the public perception usually is against the fire. They see a fire on TV and they start to panic and everything must be stopped. And even after the fire, there is this urge of the population to do something. Everyone is asking, what can I do? Should we go to the burnt areas and throw orange peel there just to increase organic matter in the soil? Should we bring seeds and throw them away? And this is something also that has to be managed in the media, no? The perception, to change the perception of fire in the public.
Yeah, but as long as the media is just only showing drama, this is not so easy. Yeah.
Great discussion. So who is going to present next? Tell me, do you want to? Because I think I have your presentation already on the computer.
Yeah.
Thanks,
I will
Saskia.
do the fire, global fire partnership later. Here.
George, you have another presentation by Marcos, okay, in this pen drive.
This one?
Yes.
Okay.
One.
It's on the.
There is another one by Marcos.
Well, I start with a project that is funded by the Prima. For many, many years in our research team in Valencia and many other research groups in Europe, we have been trying to understand the effect of forest fire on soils, soil erosion, water resources, and so on, and also in agricultural land. Then, but we also developed some solutions. But how much these solutions are being used? This is one of the topics that React for Med is going to research in the next 3 years. Is Yanis Daliakopoulos, who is the main researcher, the chair of the project. Pass the next one. And with Yanis, I should pass here. Okay, this is the partnership of a group of researchers, and we are trying to understand how is the process of degradation, of soil degradation, which induce and desertification, and how to mitigate this. Then some of our research was developed in agricultural land, and we found that all this land that you see here that looks a desert, but it's how we crop persimmon, oranges, and we look for solutions. For example, here we compare tillage with no tillage, and then as soon as you remove tillage and you have a grass cover, then you reduce the amount of runoff. Then runoff starts later, is less in quantity and less sediments. When we have the Mediterranean ecosystem, but also now the north of Europe. Every year that I come here in to north of Europe in summer, I see that there are drought. I can see more yellow the landscape. In the past was greener. Last year you suffered in Germany, also Belgium, a part of the Netherlands, a big thunderstorm, a big flood, which is typical from the Mediterranean, very concentrated in one place. You know, in the Mediterranean, in the 50s and 60s, we have a lot of casualties of people dead by floodings by the big rivers. 50 years later, we don't have casualties. We control the big rivers because we know that it will take 1 day, 2 days, 3 days. Then we advise the population move from the riverbanks and nobody died. But now we still have a lot of people dead because one small river that in a sudden flood is flooding the town. This is what you had here. I think you have the weather, the climate is getting more Mediterranean in north of Europe. And then what we are doing is evaluating how some strategies are positive to react against the desertification. These different regions have different strategies. And also, we want to apply this to a large area to see how this is being applied. For example, in my research, we are going to see how to use a mulch of the pruned branches has been improved or have been spread in the region, and which is the effect. For example, carbon sequestration, reduction in runoff, improvement of in the soil. Okay. Then In areas affected by forest fire, what we did is just to measure with different plots, sometimes trying for simulators, the effect after the forest fire. If I show you this picture, you will see, well, this is not an area affected by forest fire. I'm still not too old, and I have seen this land burned twice. I'm 57, yeah? But I saw this land burned when I was 12, and later when I was 35. Then even with the life of a person, you see that fire is part of the system. It's like to try to remove the water of the rivers because they flood the cities. Okay, this is what we have. One day, usually in summer, you have this. And then this is what the news, you can see in the news. But they don't show this. This is 3 months later. This is Quercus coquifera, it's a shrub that can be 3 meters tall after 20, 25 years. And it's sprouting. Then this is 10 years later. Then I show you this, you say, no, there are no fire. Yes, there are fire. This is a mixture of some plants like Quercus coquifera, who is a sprouter, you have seen in the other picture, and Rosmarinus officinalis, who use the seeds. And they spread a lot of seeds around. And then this is the strategy. These are some of our experiments with a lot of plots to measure the effect of different type of ash. For example, here in this experiment, we measure the effect of 2 different type of ash. Here it's very simple, black and white. If it's white, it's very dangerous. Okay. Because the bulk density of the ash is very high, the grain size of the ash is very thin, and then the ash can clog the pores and can create a crust. Meanwhile, if it's black, the porosity is much higher and don't create these cracks. And why is white or why is black? Is because the temperature. As higher is the temperature, wider is the ash. If the temperature is very low, it's very black. Well, this is some of images working with the plots, and these are an example of plots that we measured. Well, this is we have for 5 years the plot installed, and these are the rainfall month, and these upper plots are the amount of runoff that we got. This is the amount of sediments. This means every time that there is a rain, you need to go to visit the plots, take the samples, bring to the lab. And these numbers, what we were trying to see is if it's, this in a graph is easier to see. But I just put the other numbers because then you can see how much work is to, at the end, to say that there are two type of plants, which are Ulus parviflorus and Rosmarinus officinalis, that induce a higher runoff discharge. Then after the fire, you have different plants. And we isolated different plants with different plots. And what we found is that Pistacia lentiscus and Quercus coquifera, they have less runoff. And this is soil erosion in tons per hectare. After 5 years. Okay, you can see that in the last year, almost there was no changes in the soil erosion. This is the effect of the rainfall intensity. As higher is the rainfall in 1 day, higher is the erosion. And then we did some statistics to show the differences. And what we found is the following. It's written down and not in a graph. It's, probably we can discuss about the results. Well, after 5 years, which is more than 150 events of rainfall, 10 rainfall events created 80% of the runoff, which is more than 90% of the erosion. Then what is important is the intensity. It's few events is the ones that create the soil losses. And when we compare different plants, we have seen that there are plants that produce more runoff than others. And these are the sprouters. The ones that sprout are the ones that get the cover faster. They maintain the root system. Then you see a plant that is for you is 5 or 6 years old, but in fact this plant can be 200 years old. And then the root system is huge. And this is probably the main issue. And then for erosion is the same. There are less erosion, half in this kind of plant. Then, but the question is now, after forest fire, one of the main topics is we need to afforest the land. You will see all the policymakers, they want to do something. Many foresters, they want to do something, like to plant something. Few people I have found in this world that they say, no, let's go to allow the ecosystem to evolve alone. Okay? With this part was evolved alone. They have the two species. But when we plant, we decide to plant this or that, it's because the plantations, you decide if you have more runoff or less runoff. It's double. It depends on what you plant. Okay?
You can be lucky, right? It depends also on the distribution of the rain events.
Yeah, but we suppose that the rain event will be there. Okay? But if you plant Ulus parviflorus or Rosmarinus officinalis, you will have almost 4 tons per hectare in the first 5 years. If you plant Quercus coccifera, or you have Quercus coccifera already there, 1.5. Any manager will pay a lot of money to reduce to half the soil erosion. Okay? Then this is to discuss what we do after the fire. We should do something or just allow the land to manage by their own. Okay, that's all. Are now questions?
Thank you, first of all.
We can't say that we don't do anything, but someone will come that we want to do something, which are the politicians.
Yeah.
I can tell you, this summer, half of Galicia, the region where I'm from, burned, including one of the endangered 2,000 protected areas. The first thing they did is just to send everyone from the government there to evaluate what can we do. Let's start to give money. Well, first money to people that lost their homes, and then money to producers that lost cattle, and they even gave money to hunters associations because they couldn't go and hunt, because there were no more rabbits anymore, they went somewhere else. So it's just throwing money to the problem is what they want to do. So throwing money to the problem means acting there, taking the picture, and appearing in the media. And this is a real problem from my point of view, that they want to do something when sometimes it's better not to do anything.
Yeah, I have seen, in the name of the forest fire, I have seen many mismanagements. In a town nearby Valencia, after the forest fire of 1994, the mayor of the town make a meeting with all the representatives of the political parties of the town, and all of them together, they decided to plant Aleppo pine with drip irrigation.
Wonderful.
But they didn't know that they will need like 10 million more water to afforest the mountain than the water they are using for irrigating the agricultural land, which is impossible to pay. It's something crazy. Of course, never took place. They did not have the resources. Or in Spain, in some areas, the budget for restoration after a forest fire, which is for free if you do nothing, reached 7,000 euros per hectare. the two crops that are more expensive in Europe to crop are citrus plantations and banana plantations in Canary Islands. There are two more which are in Malaga, that Jesus knows well, which are avocado and mango, which are also quite expensive because the irrigation, pesticides, the fertilization, and so on. But all of them are cheaper than 7,000 euros per hectare per year. Then, with the name of forest fire, we make crazy things. Instead, to allow the ecosystem to restore by themselves, which is because fire is part of the nature. Probably what is not we should do is to reduce the intensity of the fires with prescribed fires, try to manage the land. Okay, but this is a big discussion, because myself, I have in my brain a part which I'm like an ecologist, and I would like to see the nature evolving alone without any interferences. Then we have in Europe the chance to recover native forests that were removed before the Romans. And now, because we don't need these forests, we can allow them to grow. Okay, then we also need to have some areas protected to allow these forests to evolve by their own without our intervention. But all this can be done if we protect these forests with some fires around them that will avoid that a big fire will affect. This is my opinion, but one is that there are many other opinions, and we need to convince not only the policymakers, also the society. The society is receiving a lot of information with big dramas. Flames, fires, houses burning, cars burned. Even in Christmas time you see pictures of Australia where the fire burned houses, cars, that provoke casualties. Then never good information, positive information from forest fire.
Yeah, maybe we should protect sensitive soils.
Yeah, for example.
And then if we lose them, there's nothing else.
Is the soils,
That's it.
but it's also the fauna. For example, you have some fauna in one area that need a forest. One way to protect this forest, for example, in north of Spain where there are some bears, you can protect them, this forest, but you need some areas around that will be burned to avoid that a big forest fire will reach this forest. But all this means a lot of agreements, partnership, no, Saskia? Saskia is the leader of the partnership.
You want me to say something about the partnership?
Yes, do say something.
The partnership, no.
Because
Along the FIRElinks, in all our meetings, we arrived to the agreement that nobody has the truth, but everybody has some information. The farmers, they are wise people that have been living in the land.
You're the smartest group.
There are people from academia that we are well educated, but there are firefighters that they risk their life. And I have received images from firefighters from Spain now facing fires with 45 degrees of temperature in the normal atmosphere, not near the fire, which is higher. And there are landowners, policymakers, citizens, people that go to hunt or to walk in the mountains. And everybody have a truth, but how to make that all this truth will arrive to an agreement? Common sense. And then Saskia, in all these meetings from FIRElinks, she thought that we should build a group that will follow FIRElinks that will be called the Global Fire Partnership. That we all work together, accept the idea of the others. For example, now the firefighters, the big problem they have is that they risk their life because they face a forest that they never had. Now the forest the amount of biomass is so high that the forests create their own weather, their own wind, their own temperature. We always say, if the wind is more than 30 kilometers per hour, if the atmosphere is more than 30 degrees of temperature, this makes the fire impossible to stop. It's not true now.
Macht ihr mal die Tür zu?
Yes.
Bienen fliegen ins Haus.
Okay, besser. Ja. Die Beine hier.
Joining the meeting.
They're joining the meeting. We have three, I think, three
Yeah.
bees.
But what?
We have three bees that joined us.
Yeah. And now the question is that now this sentence that was used for many years is not true. Now the forest fire, because they have so much biomass, the heat is so high that they create their own wind. They create their own temperature. It's what they call 6th generation forest fires. And the forest fires cannot stop. They need to retreat.
Yeah, maybe one by one.
But what they are doing with the...
Cerrado la ventana para que cojan ahí. Las tienen como cerradas. O las sueltan un poco. Cierra la puerta para que no entre. Han entrado por la ventana.
Okay, so we need a bee rescue
The
break.
bee rescue operation is ongoing. Already
Okay, you have
rescued.
you have ready this, Saskia?
Sorry. Anyway,
Okay, so let's have a short break, right? And let's
Don't worry, leave it there. They will go out, Saskia. Saskia, you cannot do it one by one.
find it.
anyway, I can tell about the global fire
No, we
partnership.
have time, right? So just relax. I stop the screaming.
No, it's okay. I will first do this and then rescue these.
Okay.
One more.
Saskia, please
Okay,
take-
the global
But they-
fire partnership.
Saskia, you need the microphone from
Well, I did my introduction about what we thought that is necessary because what FIRElinks is trying to build will finish in 1 year,
Yes,
and then we want to.
I will explain it. Where's the pointer? The thingy? You put in your pocket?
One moment, Saskia, just
Huh?
to inform the people.
Oh yeah.
Please, it is indispensable to get the fund to sign these 3 pages, one per day. Okay? We can sign today all the pages, and then we don't have to ask every day for the signature. Okay? I think it's much better. I will write after the date here, and then you can just put your name with your handwrite, and then also your signature to verify it's the same. Because the last time they say, okay, this signature is not like the. Okay, much better too. Even you, okay, Rolf?
Yeah.
And also Florian, if you want, you can write. You are in the list.
He's in the list, yes.
Yeah, okay. If not, if someone one day, one student or someone comes, she can also include the name, and then we can show we are more people. Okay, thank you.
Yeah.
so much for
I'm
your
sorry for.
invitation.
No problem. It's very important.
Who's talking?
Okay, then the Global Fire Partnership was an idea. We were just talking and think, okay, you know, we have this really nice consortium now with a lot of interaction between all the countries. And then we thought, okay, we need to invent something that they will continue this. And in addition to that, not only continue this, but also expand this outside of Europe, because of course we can learn a lot and collaborate with people from Australia, from South Africa, from the US, where they also are in some cases quite advanced in what they do in terms of fire management. So then,
I'm sorry. Sorry. It was me.
okay. So the objective of the Global Fire Partnership is to continue the family of FIRElinks, to expand to the rest of the world, and with that, to have an impact on research and also an impact on policy, both on on the European level, for instance, or other continental levels, but also on the local or national or local level. A little bit with the, I don't know whether you know the Global Soil Partnership, which has, and the way they are managing things, I think is really well done. And of course they have basic funding behind them, which we would still need to find. But this is an example on how what they did with the Global Soil Partnership, they really put, they have had a really big impact on putting soils on the political agenda. And I think that the Global Fire Partnership could potentially also have this type of impact. Of course, we would need to work very hard to have this amount of impact as the Global Soil Partnership has had. Anyway, the mission that we defined was to contribute to prepare society, practitioners and scientists to the intensification and geographical spreading of wildfires under the impact of climate change and land use change. Then what we would like to do is to help to synthesize the existing knowledge and enhance research on fire dynamics, fire risk management, fire effects on vegetation, fauna, soil and water, and also the socio-economic, historical, geographical, political perception and land management approaches. Then we would like to connect the scientific community from different regions with each other, but also not only with each other, but also with practitioners, policymakers and citizens, to be able to boost the emergence of these new approaches to fire research, to contribute to harmonizing the way fire effects are measured, fire effects are monitored and modeled, to have synergetic collaborations, I don't know by heart, I really need this slide, between these different research groups across the world, and to raise awareness of how, like what we were discussing before, that fire is, to go from fire fighting to fire management among policymakers, citizens, and all different types of stakeholders, and potentially be able to influence policy related to fire management. So, and lastly, to contribute to facilitate to create fire resilient landscapes based on an approach that is integrated and integral, that includes these different elements, so biological, biochemical, and physical research approaches, both coming from the socioeconomic research, historical background, geographical settings, sociological settings, and the perception of stakeholders, and therefore having policy opportunities, and also taking into account the constraints that those would have. So the idea would be to make the same type of working groups as we have in FIRElinks. So in FIRElinks we also have fire dynamics, fire and biota, fire and water, fire and soils, and fire in society. So because this, I think, was already well designed, we don't need to change that. But, and then we could have regional groups. One would be Europe, of course, which would be basically the old FIRElinks group. But we could also have a regional group in Oceania, so this would be Australia, New Zealand, North America, South America, Asia, and Africa. And then the official launch will be next year in July during this the Fire in the Earth System conference that will be held in Granada, hosted by Jesus. And so first make sure to put this into your agenda to be part of it. And also besides that, we hope to be able to meet on several occasions where we could meet at least. So it could be in this Fire in the Earth System conference that will be held every year, and or in the Terra Vision conference, which will be most likely held next year in April in Utrecht again, and in 2024 also in Granada. So you can see what we have already done so far in Terra Vision on this website. So, if you would like to be linked also to this Global Fire Partnership, please send me an email with your interest, and then I will put you in the mailing list. So, that's it. And we have a Twitter account, which you could, if you look at some of the tweets that have been done today, you will find very easily. It's a Global Fire Partner.
Global Fire Partner.
Partner, without, because it couldn't be longer.
Well, like Bernard what?
Yeah. Okay, that's it. Thanks.
Thank you.
Okay, now over then to Marcos. Or you want to say something more?
All of you can all of you can be when you are part of this Global Fire Partnership.
Yeah, it's open to anybody that would like to be. If somebody says, okay, this, I really think this is really cool, and has some time to help me with building this, then you're more than welcome, because I have many other things to do, and I really in need of some help. Thank you.
I don't know if you want to have a break before. Or, no?
It's okay.
Okay.
If you like.
How do I put this?
Does it work?
I guess so. Okay, that's fine. Okay. So, hello everyone. I'm Marcos Lado. Sorry about the title. It's a little bit complex. I didn't have time to change it like Rolf in his previous presentation. And but anyway, it helps to understand what we are working on these days related to fire. We are coming from some. Okay, forget about this one. We are coming from the western part of Spain, northwest, some Atlantic coast. It's a small city of 200,000 people called Coruña. And, well, the characteristic, if we relate it to FIRElinks, is that this region is every year, weather depending, highly affected by fire. That and the north of Portugal, although the weather can be Atlantic climate with a lot of rainfall, there's a lot of fire. And fire not only by natural causes, but mainly by human intervention. Well, our university is, well, this is the city. We have a university there that is relatively new. It was founded at the end of the 80s, and there are many disciplines. One of them is where we are involved on. We work in a faculty which is called the Faculty of Science, where we teach biology and chemistry. Things improve a little bit, so these walls have been painted since the picture. But we have also some other institutes where we have our labs, relatively new as well, where you are all invited to come and to do some research there. Well, our research group is relatively small. We have a name, Aquaterra, which is not very original. We are soil scientists, which are approximately 4, and some hydrologists, which are approximately 3. Plus postdocs from time to time, technicians from time to time, PhD students from time to time. And we, as soil scientists, are very eclectic, so we work in many different topics. Since precision agriculture to biochar to hydraulic properties of the soil, and my special interest in the last years is to be involved in forest fires because, well, it's something personal, let's say. And since, I cannot pass. Sorry, no. Okay, since cheap is best, so we decided that one of the big problems, not problems, but one of the big holes in the research about soils and fire is the amount of samples that people analyze in each study. So I know, as Saskia said before, taking samples in the field, analyzing them for soil properties in the lab is very expensive. So we try to find some other tools which are cheaper and that will allow us to link to changes in soil properties as a result of fire for cheap. For cheap, nothing is cheaper than spectroscopy. And once you have the instrument that we didn't buy, we just use it, it's for free. So we are focusing at the moment in the analysis of the study of organic matter after fire. This is some work. We work in solid organic matter, but we think also it's very important to pay attention to the water extractable organic matter, which is the mobile fraction of carbon because it's transported by water down the profile in runoff, so it reaches water bodies, etc., etc. So there are different spectroscopic techniques that we can use for analyzing the water extractable organic matter. Well, the UV visible spectra, the fluorescence properties which are very distinctive in organic matter in soluble form, and infrared spectroscopy, both in the near infrared and the mid-infrared, which are also, especially the mid-infrared, have a very distinctive signature that allows us to understand the properties, or at least the functional groups of this organic matter. Well, we did. This is very nice. We have a problem. And the problem is that when you get a spectra, or a spectrum, what you get is the signal of everything that you have there, which is overlapping, which is creating some kind of integrated curve resulting for the presence of many different things there. So what we try to do is to explain changes based on the decomposition of this spectra using something that we didn't hear of today, which is machine learning. And so for machine learning, we can use many different algorithms. We can have supervised algorithms, unsupervised ones. Over there, we work basically when we have non-supervised ones, and we want to explain variability per se. We use dimensionality reduction methods. There we have a PCA that you all know, non-negative matrix factorization, et cetera, independent component analysis, et cetera, et cetera. We have grouping using clustering, or we can have, if we have a variable that we want to link to these spectral signatures, we can use both classification or regression algorithms. Well, for classification, as you know, there are many different ones. We use mainly PLS with discriminant analysis and random forest, or support vector machines, or even neural networks. And for regression, we also have different options. Our favorite one is random forest, because it's very flexible, it's non-parametric, and it usually gives good results. Well, some of the samples, well, now we are working on using not only one of the algorithms, but we try to link different algorithms to improve the predictions and analysis, or even use different spectra analyzed using different techniques, combine them in what is called the multi-block analysis. So we have several work done like this, trying to publish it now. One of them was just artificially burning the soils or heating the soils to see how properties were changing. So you see the RGB signature, of course, is going to change here. We extracted organic matter, and we measure fluorescence, which gives some signal like this. This is a excitation emission matrix of fluorescence. We can do it for a lot of the samples that we have. It's very cheap, free. And with mid-infrared spectroscopy, we also do the same. We just took, well, these water extracts and lyophilized them, and then measure the mid-infrared signature, which is very useful to understand the nature of the organic matter over there. Well, just for you to understand what we do when we have something like that, is just to take, this is different spectral signatures in the fluorescence, yeah? So we get something like a matrix. We have a lot of matrices over there. We put them together, and we use a technique which is called parafact, parallel factor, yeah, parallel factor analysis. Yeah, that's it. Well, that allows us to explain the variability in all these matrices using a limited set of components. You can see them over here. We take all of it, we decompose, and we mix them together to recreate the initial matrix as well. This is a classic analysis that is done in water science, not so much in soil science. But okay, no rush. Okay, no, it's going too much.
It's too heavy.
Yeah, well, I mean, there are a lot of slides that are useless.
Maybe it's just a formula.
Yeah, and what we did also as an unsupervised method of analysis of these infrared spectra is to use something that hasn't been used that much, which is the non-negative matrix factorization, which is some kind related to multi-curve regression or analysis that is used in analytical chemistry, but it's slightly different, and allows us to do the same, to identify few components mixed together, gives us the variability, well, of everything. Well, I think I should go faster and do something like that. Okay, so why we don't show the results of this? We'll link it to the next thing, okay? Because I thought that showing everything was going to take too long. So we put this into practice because some people can complain that results that were relatively good in the lab are not explaining what happens in the field. So we applied these techniques to some fire that happened in Tenerife with Jonai Neris. We went there to sample some things and some soil samples from the topsoil of some burnt area. And the thing is that we are interested not only on knowing how soil properties change, but what's the spatial distribution of these changes, which is also something that hasn't been analyzed that much. So in this case, because we didn't use covariates for the analysis, what we did is a simple geostatistical analysis. We designed a sampling network. We sampled there this is the perimeter of the fire. It is a pine forest, so we took 30-something samples over there, including some out of the burnt area, and we measured the fluorescence. And after doing this analysis that I just explained before, we got that all the water-extractable organic matter fluorescence signature could be explained with 4 components. If we look into the literature, the meaning of these 4 components from right to left means that more humified material, lighter material to the left. The physical meaning of these components is not clear yet. It's something that should be analyzed more carefully. But if these ones that we found in the field are very similar to ones that we found in the lab. These are the ones that we extracted in the lab after artificially heating the soils. We look up, and especially we're interested in this one. The first one, the lighter one, blue shifted excitation emission component. Why? Because when we analyze the proportion to the total fluorescence of the different components, and the blue is that one, and these are the unburned samples, we can see that when the soil is burned, the proportion of this component increases, which is a signature of fire-affected soils. It could be used as a tool to understand if a soil has been heavily affected by fire or not. Just analyzing fluorescence of water-extractable organic matter and make something like that. And since we were doing some geostatistics, so we analyzed the spatial variability of it, we calculate the semi-variogram, we put a theoretical model, well, this is more of math thing, and we do a map, a Kriging map of how this proportion of component 1, the small one related to the other fluorescent components change. And we can see that the red colors are higher proportion of this component, which means that these areas were more affected by fire than these areas over here. Fire started here and was moving downhill. This is the direction downhill. and picking up and increasing in intensity. Well, this is our R square. Yes?
Maybe you explained, but I was not paying attention well enough. But how did you measure the fluorescence?
You extract organic matter, you shake organic matter with water, we then centrifuge and we filter, and then the water extract, we put in the spectrofluorimeter directly, and that's it. Simple. It takes time, well, not with modern spectrofluorimeters that can do many wavelengths at the same time measuring. Ours, you have an excitation, you excite the sample with a radiation or light of some wavelength, and you measure the response in different wavelengths. You move, next, move, next, move, next. And then you have, for each excitation wavelength, you have a spectra of response in different wavelengths. It's very simple. It takes a little bit of time, but it's very simple. But it's even faster. Well, this is a different story. But it's even faster when we talk about mid-infrared spectra, because we do the same, and once we have the extract, we just make a pellet. We freeze dry it, and we put it in the we make a pellet with potassium bromide, we put it in the spectrometer, and measure something like this. This is a typical spectra of something. This peak here, this is OH groups, which is coupled with this one. This is OH groups, and this is something like this. So water is something like that. And all of this is something else. All of this is something else. This is organic matter. This is aliphatic organic matter. This peak here is nitrate. And all of this is different functional groups of organic matter. We can see here what we do is just, okay, I will put here some example. This is what we got in the lab. This is what we got in the field. These are different wave numbers in the mid-infrared where we get different absorbance. So we know at each band the meaning in terms of composition of organic matter. See something bonds, no? CO bonds like here, like here. And according to the intensity, this is after decomposing everything into simple components. This is what we get. Components, 3 components over here. You can see especially here, the shape is different from this one. This is important because this is something that is called, or that involves the presence of aromatic CO, oxidized functional groups. These are, sorry. I wanted to go backwards, just a second.
Maybe I can do it for you.
Thank you.
Here?
Yeah, yes. So these are different components that we get. Well,
Let's go back. I think my
okay. So basically, this is something that we got increased when we heated the soils in the lab. We did this, we ran the same analysis with heated soils heated in the lab, different origin, and they have similar response. And we know that there is an increase in these functional groups over here, which involve the presence of CO groups mostly and aromatics. And if we look at some of the components here, also these ones with aromatics and CO, compared with these other ones that are more related to the presence of polysaccharides and something like that. So there were more components. Well, this is one that we got. There is nitrates here with water. So we know that each sample had a different nitrate content. And this is just water, because maybe we didn't dry the samples properly. Well, we did something like before. We just check what happens in the unburned soils. It's a little bit erratic. We didn't find a perfect signature that could describe the unburned samples, but we saw a lot of variability. We tried to map what happens with that, and what happens is, Once again, geostatistics, semi-variogram, just to do some interpolation, because we didn't have any other supporting variable to do a better interpolation, and this is what we got. Same pattern that we got in the fluorescence. More of the components that we associate to the burn signature, and over here, much less. Similar pattern. So we are slightly confident that this is going in the good direction. Yeah? But we can do the same not only in water extractable organic matter, we can do it in bulk soil, because we can think of needing a lot of samples to explain spatial variability at some sampling event. But we can think of time evolution, sampling at different time intervals. So one example is what we are doing with some colleagues from Bragança. They took some samples in some pine stand that was burned before the fire, 2 months after the fire, 6 months after the fire, 3 years after the fire, at 3 different depths, including one at 10 to 20. And what we did here, 5 different locations for spatial, or for at least for some representativity from the statistical point of view. We measured the FTIR, the infrared spectra, and we did random forest classification. We have these treatments, the spectra, and we said random forest, do the job for us. Find differences between the 4 sampling events. So this is what's called a confusion matrix, which represents how many of the samples were taken before the fire, and how many we classify well, and how many of these are classified as burn, and how many classified as burn after 6 months, and after 1 year. So from the 15 samples we took before the fire, 13 were classified well. There is more not so good prediction when it comes to the burn, irrespective of the time. And especially after 3 years, you can see that there is a spectral signature that resembles the one before the fire. Yeah? So if we interpret this from the spectral signature, we can say that before the fire we have a distinctive, different spectral signature. After the fire also, but after 3 years, we have something that is mixed. So it's like the soil is recovering, yeah, somehow. The good thing about random forest is that gives us which of the spectral bands are good for predicting each of the classes. For example, for predicting the soils before the fire, we have these peaks over there, which are the important ones to define that the sample was collected before the fire, which involve aliphatic carbons, some aromatics. Look at what happens after the fire. The aliphatic carbons disappear. And they are substituted by more oxidized groups, This is what the theories say, no? When other studies say, burn organic matter, increase in oxidation, increase aromaticity. We can see it there. With a very simple technique, and with just a simple tool, which is machine learning. So what is the connection with drones? Yeah, which is the topic of this meeting. Why not using the same techniques, not for spectral signature of samples in the lab, but for hyperspectral imaging from drones, where you have a more dense sampling, or even from remote sensing, you know, from sentinel bands. There we have 10, 12, I don't know. We can use the same, or even we can correlate what happens with the samples collected in the field with the hyperspectral images. And I think that should be, it could be a direction to go through. Of course, you are all very way ahead of the game of the drone thing, so
Is this,
Yeah, we are joining the party late.
Is it wavelengths or wave number?
Is wave number. In the mid-infrared, we use the scale of wave number, which is more, well, it's like more standard and standardized. So yes, basically this is it. We could use similar techniques just to analyze remote sense data from drones, with the advantage of drones have a very higher sampling density, than going to the field and just collecting by itself. Or even we can do the correlation between soil sample in the field, measuring the field, or measuring the lab the properties with the spectral signature remotely sensed. And that's it. Thank you.
Marcus, I was asking about that wave number thing because a wave number of 2,500 per centimeter means a wavelength of about 4,000 nanometers. Is that true, approximately?
Well, don't make me do the math now. It's the inverse, yeah.
The problem is that with hyperspectral imaging,
Yeah, we are working in mid-infrared, but you can use near-infrared spectra. It's a little bit different, which is what is usually, if you go to the first slide, you can see that. Now we are working with both, not only, this is why I talk about multi-block. We are trying to combine both types of spectra, near-infrared with mid-infrared. If you go, this one. Okay, so this is the typical spectra that you get from near-infrared. Let me see the wave. Yeah. This is in wavelength, but you can increase the size there, no problem. Which is very, very commonly used also for these things. Yeah, but we didn't have a near-infrared spectrometer in the lab. The good thing with mid-infrared is that the chemical bonds the peaks are more sharply distinguished. Here is just the overtones of vibration, molecular vibrations, maybe more sensitive to organic matter, but also to water. So each of the techniques has problems and advantages. But
I think especially with molecular spectroscopy, the wavelength range in FTIR you showed is perfect, right? Because I think that in the short wavelengths, like even near infrared up to 2,500 nanometers, you don't have that many spectral features. Right?
Yeah, but there are many works predicting organic matter using near infrared. Oh, really? No problem. Yeah.
Does that work?
Yeah, for sure. Yeah.
You can go for hyperspectral imaging from drones.
Yeah. No problem. This is a classic. Predicting organic matter is a classic of use of infrared spectra. Yeah. That's why I was asking. You are using only RGB. Because I think near infrared, SWIR, etc., will be very good.
Because you sold in the samples in water and taken measurements, but from the drone you only have the top surface of the layer.
Yeah, but depending on the impact of fire, you only register what happens in the surface, but you can sample down and relate what happens in the surface with what happens down. It's complicating the analysis, but that's it. You know? That's life. You know?
Yeah, but the idea also of this effort is that most people would have access to an RGB drone.
Yeah, true. A hyperspectral camera is very expensive. Yeah, sure.
So that's why it would be interesting to see if it would work, even though I'm not so confident that it will, but I think it's worth to try.
It could be. I think it could be.
It would be a major benefit.
Yeah, it could work, actually, yeah. I think from my point of view, with my experience with machine learning and so on, it could work if you have enough samples and if you remove the effect of other interference, especially water in this case, because water is going to change your RGB signature. And that will influence the modeling, yeah. So
if you measure water in the field plus RGB and you can remove the effect of water, it could work. It could work. Especially if the soil is homogeneous, relatively homogeneous, you don't have big changes in texture and so on. I think it could work. But infrared is going to work for you for sure. For sure.
But then again, as I said, this is a
Yeah.
sensor that most people don't have. While the RGB camera you can even buy at
For cheap.
for cheap.
With a phone.
Yeah.
Yeah.
Because
Yeah.
we have RGB that costs 5,000, for example.
You can make a cheap infrared camera just by removing the filter. No?
Or at least just if you find the right wavelengths, then you can always make a single band cameras. which
Also,
are
yeah. I tried to remove one of these sport camera, remove the infrared filter, put a Tesco filter, and tried some pictures. I screwed the camera. I just destroyed the CCD, so I don't know if it works or not. But I read things about that. So well, for cheap, maybe it could. It's an idea. And one of the things that I forget to mention is that if we have tools like machine learning, where we have a lot of inputs, why do we use indexes that take two bands? The ratio between two bands. Why don't we use them all? Maybe we have something in green or in infrared 2 or whatever that we are not using because we are focusing on dividing infrared sphere by blue, whatever. Why not just modeling with all of them at the same time? It's not a problem.
the rule is also there. The closer things to each other might have also the
You can have correlated variables. It doesn't matter. The composition will be there. But the components will include the two components, the two bands.
Yeah, but they call it feature engineering, right? And sometimes you have to multiply two numbers you can't even think of, right? It wouldn't just go out of the box. Sometimes you have to rescale and normalize the data.
Yeah.
In DVI, you are measuring, you're basically calculating a quotient of differences and normalize the difference of something.
Yeah.
This is feature engineering. That doesn't come just because it's a nonlinearity. If you just use a linear model of R, G, and B, you will never end up with such a functional relationship.
Yeah, that's why you use training and validation, right?
Yeah, but anyway, so if you just use R, G, and B, and you try to, because what we have in the end is, if you think of convolutional neural networks, it's a linear combination of these features. And in the end, the only nonlinearity is basically the activation function. That's the only linear portion of it, right? But it can never generate a multiplication of two variables in the network. You can never say, so the network will never come up with R times B. Right? That's something you have to know in advance or play around with.
Yeah,
But
well,
what you could do is, let's say, blindly
but that,
think of all kinds of indices and parameters and so on, and let it run, and then in the end you do a kind of sensitivity analysis or dimensionality reduction where you say, okay, these features are important, and those features are important. That's
but that's the problem with neural networks, right? They're a black box. You just input data, get the results. Results are good. You don't know what's going on inside.
Use a support vector machine or whatever, or regression.
Also,
or
but when you can explain the variable of the important variables for prediction, and if it has some physical meaning behind it, this is the key. No?
Yeah, but you see, when you do what a PCA, for example, what it does, it rotates coordinate systems.
Yeah.
It's nothing but the linear combination of two old axes, right? Vector 1 weighted plus vector 2 weighted. It's a linear combination of your old coordinates. It never generates a nonlinearity. So that means when you have, let's say, maybe there is a cool feature, I need the differences, and I have to divide this by a sum that can never result from a linear operation. Right? These nonlinearities, you have to feed them somehow into your features. That therefore I think you cannot really avoid, and that's also, let's say, previous knowledge, this prior knowledge, when you know that there's that the NDVI, for example, worked quite well to discriminate, let's say, high values of plant health and low states of plant health, why not using it together with other variables? I totally agree. And then we come maybe up with, let's say, something which has been successful in the past to discriminate different states of plant health plus other factors which we which we may have overlooked.
Yeah, well, don't misunderstand me. I'm not saying that indexes are not useful. Yeah,
No.
especially NDVI. We know it has some relation with photosynthetic activity or water stress. Yeah, in the plant. Yeah. The thing is that when we look for or we try to define what's the fire impact in soil, what is that? Changes in organic matter, changes in clay content, increasing hydrophobicity. So it's very difficult to define what the impact is.
Yeah.
So what are we measuring when we take infrared 1 divided by blue? What are we measuring? We don't know. Yeah, so if we don't know, why don't we use them all? That we don't know what they mean either. So that's it. No, I'm not against indexes. I'm just saying that in some cases, we are not using all the information we have.
Great, fantastic.
Thank you. I'm sorry, I knocked you off on this.